So we will see important JavaScript concepts in this video. So first is the global execution context. What is a global execution context? So this is a JavaScript program. So while executing a JavaScript program, a JS engine, it creates a global execution context which will have a memory component and will have a code component. So in the memory component, it will have basically it will have a key value pair, like for every variable what is the value, and if it is a function now it will have the function code, right, and then square 2 is a variable. So initially it will create this memory. Initially everything will be undefined, so it will be undefined and it will have a code component. For the code component, right, so you need memory for all the variables and you need code for the functions, right? So inside the code component you have another function, correct? And for this function there will be again an execution context that will again will have the memory and code. So for this function, right, for the square function, what you will have, you will have basically memory component which will have num, correct? And you will have ans. Okay, so what happens is when your JavaScript starts executing, right, first of all everything will be undefined. When it starts executing, that value will be assigned to in the memory. Okay, so similarly what happens here, this will be the code component, and while executing this code, right, this will be the thing, and while executing this code, answer is num into num. So it will basically it will allocate a execution context for the function square, and then it will execute. So when this line is executed, 2 will be assigned here, and this square will have this function code, and then you're calling the function again. When you're calling the function again, right, that time, right, basically it will control will come here, and each line will get executed. When each line is executed, right, so when you're calling square here, right, you're passing n is 2, so num will get 2. Okay, and answer is num into num, 2 into 2 4, then answer will be assigned to 4 in the memory. And so and return answer, when you return from this, right, this execution context will be freed up. This will be deleted because this function is returned, right? Again you call the function, the again execution context will be created, and then the same thing happens, right? Num will be assigned to 4, and then num into num is 4 into 4 is 16, and then return 16. This execution context will be deleted. Okay, now after this, right, you are returning 4 here, right? This 4 will be assigned to square 2, and 16 will be assigned to square 4. Okay, so this is how execution context works when you run a program, right? So this is there will be execution context for your program, right? That is the global execution context, and there will be execution context for each functions, right? That will be part of the global execution context. If you are calling any other functions from here, right, inside this, if you have any other functions now, again this code will have execution context for that function. Okay, so this is the execution context, and important thing you have to understand in JavaScript is the call stack. Now what is call stack? Call stack in JavaScript, all the functions which has to be executed, right, that has to be placed in the call stack. Whatever function you have to execute, that has to be placed in the call stack. After coming to the call stack, only the function will get executed. Okay, so the call stack will be something like this. First you will have the global execution context, right, that will be placed in the call stack. Then what you are calling, you are calling this square one, right, so that will be again placed in the call stack. Okay, once it is executed, it will be removed from the call stack. Okay, so basically when you want to execute a function in JavaScript, that has to be placed in the call stack. So that is what you need to understand. Okay, now you have heard of something called as event loop. Okay, now what is event loop and why it is required? So you all see that this is a call stack. Okay, and basically a JavaScript engine, right, that only executes the function in the call stack. Okay, but in our function, our JavaScript code, where it executes in the mostly in the browser, right? When you use JavaScript for the front end, the browser executes your JavaScript code. So our JavaScript code has access to web APIs which are provided by the browser. So these are the kind of web APIs which is provided by the browser, right? Set timeout, DOM APIs, right, which you use document.get element by ID, document.query selector, and fetch function and all, right? These are all part of web APIs, right? So if your JavaScript uses these functions, right, you have to execute in the browser only. Then only this your JavaScript code will get executed. Okay, so now, so this is how it is basically, right? But let's see what is event loop, what is the need for event loop. Okay, okay, so now here if you see, right, there's a sample code which is getting executed here. Okay, here you have a set timeout and you have a function passed to set timeout. So set timeout has two arguments, right? One is a function and a time. So after this time elapses, this function will be called, right? This is 5000 milliseconds. This after 5 seconds, this function will be called. Okay. Now, when you do a set timeout, right? Basically, what you are doing, you are calling your web API only. So what the web API does, this timer and all is part of browser. All these things, right, which is all part of browser only. It is not part of our code. It is not part of Java engine runtime and all. It's all part of browser, right? So when you call a set time mode, right, what it is, you have to provide a callback function, right? So you are registering, you are putting the callback function in the web API environment. Okay, so you are putting the callback function in the web API environment and you start a timer for 5000 milliseconds. Okay. Now the question is, after 5 seconds, this function has to be executed. But what I told, if the function has to be executed, it has to be put in the call stack. So somebody has to put this function in the call stack, correct? So what happens is, after this time elapsed, right, this callback function is placed in a callback queue. Okay, and there is one process as the event loop. This event loop is responsible for putting the function from the callback queue to the call stack. Once the function is put in the call stack, you get it executed. But this event loop will put this function in the call stack only if the call stack is empty. Until then, it will wait. Okay, so what happens is, this will be like okay, so how this code will get executed? This code will get executed like this. Okay, you will have a global execution context which will be placed in the call stack, right? And this statement is executed. Start is getting printed, and then set timeout function. So you are calling a web API. Okay, you are registering this. Okay, so basically the set timeout is an async function. Okay, we'll see what is an async function in details later. So this will keep on waiting, right? Until then, this is the main thread. Okay, so you have to understand that JavaScript is follows synchronous single-threaded execution. JavaScript is synchronous and single-threaded. So what is synchronous? Synchronous means it will execute line by line. Okay, it will execute line by line. If this statement is taking some time now, it will wait for the statement and then it will execute the next statement. This is what is synchronous. What is so one execution of one statement has to wait. Then only the next statement will be executed. Asynchronous means while the statement is executed itself, it will not wait. It can come and execute the other statement. Okay. So JavaScript is bisynchronous and single threaded. Single threaded means while executing some part of the code, right, all is in one thread. If it is multi-threaded, some part of the code execution in one thread and other part of the code can execute in other thread parallelly. Okay, so this is very important. JavaScript is synchronous and single threaded. Okay, it will follows one line of execution. That's it. If it starts now, it will keep on executing. Okay, but if there is any async operation happening, async operation which can happen in parallel, right? What will happen is now you see, right? This set time mode, right? This is an async function, right? When this set time mode has to be called, it has to be put into the call stack only. But what happens is when it waits, right? The set time mode, it will basically wait for 5 seconds, right? So what will happen is it will get suspended from the call stack. You put in the call stack for execution of the function. Suppose you have async function, you will put it in the call stack for executing the function. But if the async function is waiting, that will be suspended in the call stack. So that what else is in the call stack, that will get executed. Okay, that is how async function works. So that any async function you have, it will not wait for the function to complete. Okay, so similarly here set time mode will not wait for that 5 seconds. It will come and execute the end. After 5 seconds, you get this callback print here. Okay, but how this works? This is how it works. You put in the callback function in the web API environment. From the web API environment, after 5 seconds, it moves to the callback queue. From the callback queue, event loop puts the function in the call stack if the call stack is empty, and it gets executed. Okay. The same thing happens with the event listener also. Okay, in the event listener also, what happens? You basically register a callback function. Like for a particular button, right? You add an event listener, click. So whenever you click this button, this function will be called. Right? This is what is DOM manipulation, right? Document.getElement by ID. Okay, so this function will be called, and the same thing, this function again will be put in the callback queue. Why you maintain a callback queue? Because many times you click this function. If you click many times it will be added to the callback queue. Okay, and again from callback queue, event loop will place in the call stack. Okay, but in the case of fetch, it's a little different. Okay, so suppose you have now here there are two callback functions. One is CBT, this is for callback function for a timeout, and CBF callback function for a fetch. Now you are fetching some information from netflix.com. Okay, and then when the data comes, right, then this callback function has to be called. Okay, now in this case what happens is this fetch is also a web API, right? So after the data is fetched, right, you have a callback function that will be there in the web API environment. Okay, but in this case, right, this will be put it will not be put it in the callback queue. It will be put this fetch return, right? Whatever the callback function of a promise, that will be put in a micro task queue. Okay, what is the advantage is this micro task queue, right, has higher priority. Okay, if there are a lot of function in the micro task queue, event loop will take the function in the micro task queue and that it will put that one only in the call stack. Okay, once this is empty, then only it will go to the callback queue. So all the promise callback functions and all, right, that will all go to the micro stack queue. So if you see the execution, right, first start will get printed, and then these are all callbacks, right? So it will wait for the data. So our main thread will not wait. Okay, so main thread will come to execute and print the end. After the end comes, right, what will be put in the callback queue? First will be CBT after 5 seconds, and this will be CBF, right? So this will come, this data is coming in 50 milliseconds. So this will be put in the micro task queue. And event loop will take this function and put it in the call stack, and our CBF will get executed. CBF will print CB Netflix. So CB Netflix, and then this function CBT will be put in the callback queue, and from the callback queue you will get executed, and you will print, get the CB set time mode print. This is how the execution happens. Okay. See, when you call async function and all, right? Async function, which means that what it can execute in parallel. So our main thread will not wait for this function to complete. It will be put in the callback queue for execution. But once it starts waiting, right? It has to fetch the data, right? So it has to wait. So when it starts waiting now, this execution will be suspended in the callback queue. And once it's returned, then the execution will resume. So our main thread will not be blocked. That is why before these prints and all, after the start, end print is coming.